So hi, today the main topic is like let's review the journal which is the ubiquitous B3. I think this research paper, this journal is really predefined. It is really easy to read. Even like I guarantee that 7 grades old and middle school the student can read this because the the vocabulary is really simple and and the yeah, it's not really hard. Example, the secondary storage facilities available on large computer system allow user to store, update, and recall data from the collection of new information course files. And this, I guarantee, I also read this sentence, and I don't think that's too hard. So basically, um, and also this research paper is good because the algorithm and data structure isn't came out from the nowhere. We somehow face the problem. We think about how to solve it, and we just found out how to solve it. So there's a sequential and random and whatever thing, and in in this file there's could be random because um, if it's really hard to make the data as a sequential because if you make some kind of data has to be orange per the user the user sign or whatever do is it's gonna be really hard because the database has to operate per the user data entrance. So if there's like 100 user and the per seconds and really at the time there should be some big operation in the database and that could lead some kind of cost or the latency of it. And we just insert the random value. Example from my employee file, extract the information about employee J Smith. We don't know about J Smith. We just have to find it from the J Smith the data. Example, there could be J Smith name of it. There could be the employee ID, and um, most easy thing is using ID because the if you have a work experience, as I also have a work experience, when you're trying to go to work and if it's your first time, you will get your own ID, which is also for your laptop, whatever thing, but that is kind of really your unique ID because there could be duplicate of your name. My name is Merlin, and my employee could their name could be Merlin, so there's gonna be conflicts of it. So we have to make the data as a unique. So that's and this sorry, my running nose. And this thing is also called a key, and this explanation is actually written here. Let's find the record. I think there's record libraries in the drawer. Yeah. So there's index, and index is basically um, there could be. Wait, let's find the record. Record. Yeah. So in record, employee record has and inside employee record there should be undefinite and unique key, right? So there's a, for example, employee might assign unique employee number which would identify the employee record. So even single data has to be record because you have to find it. And the when we but how about but the thing is that when you're trying to find some kind of the key, you don't have to really you don't have to traverse all of the employees and go inside the employees data record box and have to extract the ID, and that's kind of really tedious. So that's kind of sorry, and that's the problem that we face, and we somehow trying to make this kind of thought that well, why don't we have to get all of the employees box, the record box, and get the ID key and put it into index file, and so we can just search for the index file rather than going to the all of the employees record key. So that's called the index. Index is just the group collection of the record keys, and I think there is already written here. Also with the large randomly accessed file in a computer system is an index which like the labels on the drawers and folders of the cabinets be retrievable by directing search to a small part of the file containing the desired item. The figure one is this PDF of the index file. So if you look at here, as I say, the records like a box thing, but it gets the record key, and this index has a key, and also it has some kind of reference to the target record destination of it. And so the next thing you have to think about the index file as if you look at the database here, and for the purpose of the paper, we think of the file as a records, and like I said, it's just the bunch of collection of the records, and each form has the n, and so a key. So the unique ID is gonna be key, right? Yeah. So for example, the key for a record is in a amplifier might be 5-digit employee number, as I said, the ID of it, or might be name or address. We assume that key uniquely identify record key. So key equals to the identifier with the record key. So that's kind of be re-ID thing in our modern days. And now next thing you have to consider as a reading this kind of thing. And if you have a question about bit tree, why do we have to think about like optimization for it? Because we don't really store that in the RAM. We have to store it on the disk file, because it has to be stored after you turn off your computer. It has to be sustainable and managed even though you turn off it, because that's how a database works, right? And the thing is that to operate those kind of secondary memories, secondary operation is slow. Yes. The reason why it's so slow, because it's not written here, but yeah, I know, since the set of the OR key does not fit in the memory, and that's also true. But what I think about the reason it is slow is because it's the way of how hardware and how computer architecture looks like. Because the memory RAM is really attached to the CPU, because there's a lot of cache here, R1, R2, and there's also TRB. TRB also TRB cache. Yeah, TRB is it's just the like kind of hash map. What is this? Hash map memory management for the virtual address. And there's the bus, data bus, address bus, control bus. Since CPU, they really have attached with the memory, because there's a data bus and address bus and control signal bus, if you look at here. So that's kind of really related, but this is kind of really far from here. It doesn't really attach to it. So you have to really make it faster, because the database, the import database read operation and search operation, whatever thing operates has to be fast, because you want to get the data. If there's latency on the server, your client will be angry. So that's kind of really thing about like Bittree, yeah, to understand like why it doesn't made, and why those kind of problem, why do we have to store as a secondary thing and whatever thing. And next thing is the limitation about the purpose data structure, which is the binary tree. It's saying a lot, but there's a proposal of the B tree, and before B tree there's such a thing as a binary search tree, but the problem is that it could lead some kind of problem, which is can have the multiple we have a problem that it only have one children. So the time complexity could be, the worst case can be O(n) squared. So that was a problem. So we just have somehow to use the B tree, because the time complexity, the worst case is O log n rather than O(n). Oh yeah, binary search tree, the search operation, the time complexity O(n) rather than O log n. So we have to make it faster. So this kind of really thing about like B tree thing. I cannot read this whole papers because there's so many time. I don't have much time, but I really recommend you read this stuff. It's not really hard. It's it's more better than some kind of like whatever example Korean SAT. If you look at the Korean SAT English part, it's actually bullshit. But this one is explains really well. I think they're really genius. I don't know his name. Yeah, Douglas Comer. The introduction part. He wrote it down the like kind of the background to understand those kind of data. How do we handle the data, sequential and random? And next he talks about the record using example of employee, and that is and he explained with the index file with the record keys and whatever stuff. And he also talks about secondary memory rather than main memory, and why do we have to make it faster, like this part. So it's really perfect, it's really nice. So I guarantee if you read it you will learn a lot of things. So this is it. Have a nice day. See you next time. Bye bye.